A vertical shaft Francis turbine rotates at 300 rpm. The available head at the inlet to the turbine is 200 meter. The tip speed of the rotor is 40 meter per second. Water lifts the runner off the turbine without whirl. Velocity at the exit of the draft tube is 3.5 meter per second. The head loss in different components of the turbine are: number 1, stator and guide vanes 5 meter. In the rotor, the head loss is 10 meter, and in draft tube it is 2 meter. Now the flow rate through the turbine is 20 meter cube per second. And assuming G is equal to 9.8 meter per second square, we need to calculate the hydraulic efficiency of the turbine. And that we have to calculate in percentage rounded off to 1 decimal place. Now for a Francis turbine, the hydraulic efficiency, let's write eta H for that, is given by head in the turbine. Okay, so let's write HT for it, divided by inlet head, HI. Let's write HI for inlet. Okay, let this be equation number 1. Okay, now to calculate this hydraulic efficiency, we need to calculate HT, that is the turbine head. So the inlet head of the Francis turbine, we can write it as HI is equal to turbine head plus the head losses, all losses, head loss. So head loss will count with will take the count of stator, the rotor and the draft tube. Okay, so these are the all head losses plus the head at the end of the draft tube, right? So for that we write, usually the notation is V3, so let's write here V3 square by 2G. Okay, and these losses are given to us, the stator, the rotor and the draft tube. So from here we can calculate the HT value because HI is already given in the problem. So HI given in the problem is 200, right, is equal to, let's write HT plus, we'll add up all these losses, head losses. So this is 5 for stator plus 10 for rotor and plus 2 for draft tube, plus now V3, that is the velocity at the end of the draft tube, that is given as 3.5 meter per second. So square divided by 2 times of acceleration due to gravity, that is 9.8. we have to consider this. So from here we'll get the value of HT as 182.375 meter. Okay, and now we can calculate, we can substitute this value of HT in the first equation to calculate the hydraulic efficiency. So eta H will be equal to 182.375 divided by HI, that is 200, and this will give 0.911875. Okay, and in percentage we can write eta H is equal to 91.1875%. Let's go back to the problem and fill in the blank. So the hydraulic efficiency of the turbine is 91.18. So okay, we need to round off it to the 1 decimal place, so we can write 91.2%. To get more detailed information on the hydraulic efficiency or the head losses and how do we calculate this, how do we obtain this formula, you can refer to the NPTEL course on Introduction and Analysis of Forces on Francis Turbine, Part 1 by Professor S.K. Soam of the Department of Mechanical Engineering at IIT Kharagpur.